Good morning all. In the last two classes, we have discussed the basic of sets and their representation. We know that we can represent a set in two different ways. One is called roster form and second one is called set builder form. In roster form, we list every elements of the set, separating the elements by commas and enclosed within braces. In set builder form, a set is represented by stating the single common characteristic property possessed by all the elements of the sets. Today, we are going to do some problems relating to this section. Section A, I mean classroom discussion. Today we are going to do 8 problems. All problems are dealt with conversion of roster form into set builder form and set builder form into roster form. Let us see our first question. Write the following sets in roster form. Set builder form is given. What is first question? Question A. A is equal set of all x such that x is an integer and negative 3 less than x less than 7. We want to write this set A in the roster form. Let us start. Answer to question number A. A equal to. We want to write this set in roster form. For that, we want to list every elements of the set, separating the elements by commas and enclosed within brackets. I open the bracket now. Now, which are the elements in the set? X is an integer and negative 3 less than x less than 7. Negative 3 is here, 7 is here. We want to write all the integers in between negative 3 and 7. Which are they? Negative 2, negative 1, 0, 1, 2, 3, 4, 5 and 6. These are the integers in between negative 3 and 7. As you know, by integer we mean a number without any fractional part. So, when we write this set in roster form, we list all these numbers here, separating the numbers elements by commas and enclosed within brackets. Let us start. Negative 2, negative 1, 0, 1, 2, 3, 4, 5 and 6. Then enclosed within brackets. Okay. Now answer to question number B. B is equal set of all x such that x is an integer. Here also x is an integer. And the condition for x is that negative half less than x less than 9 by 2. The integer must be in between negative 1 by 2 and 9 by 2. Clear? Now let us write. Where is the location of negative 1 by 2 in number line? The midpoint of 0 and minus 1 here. And where is the location of 9 by 2? That is 4.5. The midpoint of 4 and 5. Here is 9 by 2. We want to write all the integers in between these two numbers. Which are they? 0, 1, 2, 3 and 4. Write the all elements, separating the elements by commas and enclosed within brackets. This is called roster form. Now we converted these two sets in set builder form into roster form. Clear? Now write this question and answer in your notebook at first. After that, see question number 2. What is question number 2? Write the following set in roster form. Another question. A is equal set of all x such that x is an integer and x square less than or equal to 40. Let us start. Answer to question number A. A is equal to. We want to write all the integers. What is the condition of that integer? Square is less than or equal to 40. Which are the integers? Where is square root of 40? Square root of 40 is about 6.32. Its location is here. And another square root of 40. That square root of 40 can be divided into one is positive root and another one is negative root. So negative square root of 40 is here. Negative 6.32. We want to list all the integers in between negative square root of 40 and positive square root of 40. All the integers in between negative square root of 40 and positive square root of 40 satisfy the given condition s square less than or equal to 40. Okay. Then which are the integers? Negative 6, negative 5, etc. to 6. Let us write it. Negative 6, negative 5, negative 4, etc. to 6. Now, this is this roster form of this set. Then what is question number B? B, the condition is same, but in that time, x belongs to the z plus. The set z plus, that is set of all positive integers, that is set of all natural numbers. That is, we want to write all natural numbers from this set. Which are they? 1, 2, 3, 4, 5 and 6. Okay. In other way, we can say that the set of all in positive integers satisfying the condition s square less than or equal to 40 are 1, 2, 3, 4, 5, 6. These are integers. Square of that integers must be less than or equal to 40. So let us write them 1, 2, 3, 4, 5, 6. Okay, and set question number B is also over. Write neatly into your notebook. Now move to question number 3. What is question number 3? That's a very simple question. Write the following sets in roster form. Here there are two sets are given in set builder form. First set is A, and its condition of each element is that x is a solution of the equation s square plus x plus 2 equals 0. Now let us answer it. S equal to. We want to write this set in roster form. For that, we want to list all the elements of the solution of this quadratic equation. What is the quadratic equation? S square plus x minus 2 equals 0. We want to solve this. How can we solve this? We want to find two numbers whose sum is plus 1, positive 1, and product is negative 2. Since the product of the two numbers is negative 2, it is clear that the two numbers are different sign. One is positive, another one is negative. Then which are the numbers? We want to get two numbers whose product is 2, 1 and 2. It is clear. Since they have different sign, one is negative 1, another one is 2, or one is 1 and another one is negative 2. Then how can we recognize this? How can we identify their sign? By seeing here. The sum is positive 1. Since the sum is positive 1, the biggest one is positive. That is, 1 and 2 are the numbers. The biggest one is positive, means 2 is positive and 1 is negative. Therefore, the desired numbers are plus 2 and minus 1. Therefore, we can write this quadratic equation as a product of two linear factors as x plus 2 into x minus 1 equals 0. Product of these two term equals 0. What is the meaning? Either x plus 2 equals 0 or x minus 1 equals 0. It means that x is equal to minus 2 or x is equal to 1. These are the solution of this quadratic equation. Therefore, we write all these two numbers here and separating the elements by commas and enclosed within brackets like this, minus 2 1 and enclosed within bracket. This is the roster form of this set. Okay. What about question number B? Question number B is set of x such that x is a solution of the equation s square minus 9 equals 0. S square minus 9 equals 0 is again a quadratic equation. It is very easy to solve. S square minus 9 equals 0 like this, s square equal 9. We want to find two numbers. We want to find a number whose square is 9. Is clear. One is 3 and another one is minus 3. Or we can solve this like s square minus b square equals 0, a minus b into a plus b equals 0. In the same way, s minus 3 into s plus 3 equals 0. At that time also we get the answer x equal to 3 and x equal to minus 3. We write these two numbers here, separating the numbers by commas and enclosed within brackets. Now we get the roster form. Clear? Now let us see what is question number 4. Okay, before that there is a quadratic formula. Every one of you learned in class number 10. that this quadratic formula. You can this quadratic formula also to solve this quadratic equation. But here this method is very convenient. That is why I used here this method to solve this quadratic equation. Okay. Now see what is question number 4. Question number 4 is this one. Write the following set in Rorschach form. First set is S equals set of all x such that x is a divisor of 60. Which are the divisors of 60? It is very clear. 1, 2, 3, 4, 5, 6, etc. Okay. For that, if you have any doubt to find how to find the divisor of 60, you just write like this. 1 into 60 equals 60. 2 into 30 equals 60. 3 into 20 equals 60. 4 into 15 equals 60. 5 into 12 equals 60. 6 into 10 equals 60. And what about 7 into 1 thing is equal 60? No. 8 into not equals 60 and 9 not equals 60. Then 10 into 6 equals 60. Then this sequence repeated. Okay. It means that the divisors of 60 are 1, 2, 3, 4, 5, 6. Then 10, 12, 15, 20, 30 and 60. These are the divisors of 60. 1, 2, 3, 4, 5 up to 60. Okay. I wrote all the divisors of 60, separating the elements by commas and enclosed within brackets. Hence, this is the Rorschach form of this question. What about question B? B set of all x such that x is a prime divisor of 60. We want to set the prime numbers among these. Which are the prime numbers? Is 1 a prime number? No. 1 is neither prime nor composite. What about 2? 2, 3 and 5 are prime numbers. What is a prime number? A number having only 2 factors. Okay. What about 4, 6, 10, 12, etc.? These are composite numbers. They are not prime. They have more than 2 factors. Therefore, answer to question number B is equal to set 2, 3 and 5. This is the x is a prime divisor of 60. These are the prime divisors of 60. Okay. If the question is B is equal to set of x such that x is a prime divisor of 60, then without finding these all divisors, we can write this. How? Just factorize like this: 60, 2, 30, 2, 15, then 3, 5. 16 can be written as 2 into 2 into 3 into 5. It means that the prime factors of 60 are 2, 3 and 5. The prime factors of 60 are 2, 3 and 5. Without writing all the factors of 60, we can find the prime factors in this easy manner. Clear? Write into your notebook. Then answer to question number 5. Question number 5 is this. S equals set of all x such that x is a 2-digit natural number such that sum of its digit is 8. We want to write the 2-digit natural number. Sum of the digits of 2 natural numbers is 8, which is the smallest 2-digit natural number 10. What is their sum? 1 plus 0 is not equal to 8. What about next number? 11. 1 plus 1 not equal to 8. Then which is the smallest 2-digit natural number satisfying this condition? Sum of the digits is 8. That is very simple. It is 17. What is next number? 26. Next 35. Next 44. Next 53. Next 62. Next 71. And the last 80. Okay. Then this is the Rorschach form represented in this set. Then what about question number B? Set of all x such that x is a letter in the word better. Which are the letters in the word better? First one is B. Next is E. Next is T. Next is again T, but no need to write T twice. Okay. Then next is E. E we have written once, therefore no need to write twice. Then what is the last letter? That is R. In Rorschach form, elements are not generally repeated. Clear? Answer to question number 5 is over. Okay. So far we have done some problems dealing with converting set builder form into Rorschach form. Now we are going to do some problem dealing with converting Rorschach form into set builder form. What is first question? S equals set of all x, S equals set 3, 6, 9, 12. We want to write this set into set builder form. For that, first we write set of all x such that. Next, we write the single common characteristic property possessed by all the elements of the set. Can you say which is that single common characteristic property? Yes, these all are multiples of 3. This all, x is a multiple of 3 and this is a positive multiple of 3. 0 is a multiple but not positive multiple. Negative is a multiple but not positive multiple. This is a positive multiple of 3. Is this condition enough? No. Why? 30 is a multiple, positive multiple of 3, but 30 is not in this set. Okay, 300 is a positive multiple of 3, but 300 does not belong to the set. Therefore, we must write one more condition or restriction of this positive multiple like this, x less than 13. Okay, then this is the single common character property possessed by all the elements of the set. Positive multiple, at the same time that multiple must be less than 13 or less than or equal to 12 or less than 14. Okay, we can write all in different manner. The same answer can be written in another way like this, s equal to set of x such that x is a positive multiple of 3. How can we represent a multiple of 3 like this? X is equal to 3n and n belongs to the set 1, 2, 3, 4. When n equal to 1, answer is 3. n equal to 2, answer is 6. n equal to 3, answer is 9, and n equal to 4, answer is 12. This is another way to represent this in set builder form. Another way, s equal set of x such that x is equal to 3n and n belongs to n. n is a natural number and this n less than or equal to 4. n less than or equal to 4. This is another way. You can write any one of this form when you write this set in set builder form. Clear? Answer to question number B. What is question number B? B is equal set to 2, 4, 8, 16, 32. Is this multiple of 2? No. Then what is this? This is power of 2. 2 square, 2 cube, 2 raised to 4, 2 raised to 5. In general, we can write B is equal set of x such that x is equal to 2 raised to n. n belongs to n and n must be less than or equal to what? 5. Clear? When n equal to 5, answer is 32, n equal to 4, answer is 16, n equal to 3, answer is 8, n equal to 2, answer is 4, and n is equal to 1, answer is 2. Clear? Write it into your notebook. Then question number 7. What is question number 7? Write the following set in set builder form. First one is very simple. This is set of all even natural numbers. Okay? S equal to x such that x is an even natural number. That is first method. Or we can write s equal set of all x such that x is x equal to n, multiple of 2, and n belongs to n. There is no more conditions here because this set, these elements continue indefinitely. Therefore, there is no restriction on n. Clear? Then what is answer question number B? 1, 4, 9, 16, etc. 100. What is the peculiarity or special features of these elements? These all numbers are perfect squares less than or equal to 100. Okay? Then you can write B is equal to set of all x such that x is equal to n square and n must be less than, n is a natural number and n less than or equal to 10. Clear? Or we can write B is equal set of x such that x is a perfect square less than or equal to 100. Then last question, question number 8. That is, write this set in set builder form. First question is very simple. S equal to, you can do yourself, very simple. S equal to 1, 8, 27, 64. These all are cubes of natural numbers. 1 cube, 2 cube, 3 cube, 4 cube, etc. Therefore, we can write S equal set of x such that x is equal to n cube and n belongs to n. There is no condition for n because this set continues indefinitely. Clear? What is next question? B is equal set 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. How can we write this set into set builder form? What is the common property of these all elements? When we read this number as n, then what is this? N plus 1. This is n plus 1, n plus 1, n plus 1, and so on. So we can write this as x is equal to n by n plus 1. X is equal to n by n plus 1 and n belongs to n. One more condition for n is that n must be less than or equal 6. When n equals 6, you get 6 by 7. When n equals 5, you get 5 by 6. When n equals 1, you get 1 by 2, and so on. Okay? Today's class is over. Here there is an assignment to you. Please do this assignment yourself. And as you know, only self-practice make you perfect. When you feel any type of difficulties while doing the assignment or while learning mathematics, don't hesitate to ask through description box. Let me stop here. Thank you for watching. Have a nice day. Goodbye.